Welcome to the Vector Academy. Let's look into the introduction to linear algebra for machine learning. Topics covered. Introduction. Challenges in learning linear algebra for machine learning. Linear algebra roadmap for machine learning. Introduction. Linear algebra is a field of mathematics that could be called the mathematics of data. When we talk about data modeling, computational modeling, mathematical modeling, linear algebra plays a key role. Linear algebra is widely used throughout science and engineering. Every branch of science and every branch of engineering makes heavy use of linear algebra. You can imagine the importance of this field of mathematics. Linear algebra is literally ignored by computer scientists and software professionals. It is because linear algebra is a form of continuous rather than discrete mathematics. Linear algebra is undeniably a pillar of the field of machine learning. We will discover why machine learning practitioners should study linear algebra to improve their skills and capabilities as practitioners. Challenges in learning linear algebra for machine learning. It's slow. Taking months to years to study an entire related field before machine learning will delay you achieving your goals of being able to work through predictive modeling problems. It's a huge field. Not all of linear algebra is relevant to theoretical machine learning, let alone applied machine learning. How to get started with linear algebra for machine learning? We at the Vector Academy would recommend a breadth-first approach to getting started in applied machine learning. We call this approach a results-first approach. It is where you start by learning and practicing the steps for working through a predictive modeling problem end-to-end with a tool such as scikit-learn and pandas in Python. This process then provides the skeleton and context for progressively deepening your knowledge, such as how algorithms work and eventually the math that underlies them. Linear algebra makes more sense to a practitioner once they have a context of the applied machine learning process in which to interpret it. After you know how to work through a predictive modeling problem, you should deepen your understanding of linear algebra. Linear algebra roadmap for machine learning. Learn linear algebra notation. You need to be able to read and write vector and matrix notation. You might have seen algorithms described in books, papers and on websites which heavily use vector and matrix notations. Linear algebra is the mathematics of data and the notation allows you to describe operations on data precisely with specific operators. You need to be able to read and write this notation. This skill will allow you to read descriptions of existing algorithms in textbooks, interpret and implement descriptions of new methods in research papers, concisely describe your own methods to other practitioners. Good part is that programming languages like Python offer efficient ways of implementing linear algebra notation directly without putting much effort. An understanding of the notation and how it is realized in your language or library will allow for shorter and perhaps more efficient implementations of machine learning algorithms. Learn linear algebra arithmetic. You need to know how to add, subtract, and multiply scalars, vectors, and matrices. A challenge for newcomers to the field of linear algebra are operations such as matrix multiplication and tensor multiplication that are not implemented as the direct multiplication of the elements of these structures, and at first glance appear non-intuitive. Again, most if not all of these operations are implemented efficiently and provided via API calls in modern linear algebra libraries. An understanding of how vector and matrix operations are implemented is required as a part of being able to effectively read and write matrix notation. Learn linear algebra for statistics. You must learn linear algebra in order to be able to learn statistics, especially multivariate statistics. Statistics and data analysis are another pillar field of mathematics to support machine learning. They are primarily concerned with describing and understanding data. As the mathematics of data, linear algebra has left its fingerprint on many related fields of mathematics, including statistics. In order to be able to read and interpret statistics, you must learn the notation and operations of linear algebra. Modern statistics uses both the notation and tools of linear algebra to describe the tools and techniques of statistical methods. From vectors for the means and variances of data, to covariance matrices that describe the relationships between multiple Gaussian variables. The results of some collaborations between the two fields are also staple machine learning methods, such as the principal component analysis, or PCA for short, used for data reduction. Learn matrix factorization. Building on notation and arithmetic is the idea of matrix factorization, also called matrix decomposition. You need to know how to factorize a matrix and what it means. Matrix factorization is a key tool in linear algebra and used widely as an element of many more complex operations in both linear algebra such as the matrix inverse and machine learning such as least squares. Further, there are a range of different matrix factorization methods, each with different strengths and capabilities, some of which you may recognize as machine learning methods, such as singular value decomposition or SVD for short, for data reduction. In order to read and interpret higher-order matrix operations, you must understand matrix factorization. Learn linear least squares. In linear algebra there are equations where there are more equations than there are unknown variables. As a result, they are challenging to solve arithmetically because there is no single solution as there is no line or plane can fit the data without some error. Problems of this type can be framed as the minimization of squared error, called least squares, and can be recast in the language of linear algebra, called linear least squares. Least squares is most known for its role in the solution to linear regression models, but also plays a wider role in a range of machine learning algorithms. Linear least squares problems can be solved efficiently on computers using matrix operations such as matrix factorization. Learning linear algebra is fun. Seriously. Learning linear algebra is a lot of fun. Once you can see how the operations work on real data, it is hard to avoid developing a strong intuition for the methods. Viewer will experience a knowledge buzz as they learn about the connections between concepts, and it's not uncommon to experience mind-expanding moments while studying this subject. Why do you want to learn linear algebra? Let me know. Thanks for your time. Please like it and share it in your circle. Subscribe to our channel, The Vector Academy, for more videos, lectures and tutorials. For more information, do visit our website www.thevectoracademy.org.